Now we're going to define recursive and look at how we generate them, and then we're going to use our inspires to figure out how the inspire can help us to eliminate some of the pen and paper time on doing some of these kind of burdensome calculations when we have to use a recursive function. So one of the definitions or key features of a recursive equation is that you have to build each term from the output of a previous or more than one previous terms, possibly. Like the Fibonacci is done with previous terms, not just a previous term. So let's look at one example. So let's say I want to calculate b sub 1 through b sub 5, and then I'm going to use my calculator to go out to b sub 20, because you're going to see that very quickly this is not something that we necessarily want to do by hand every time. So in this case, b sub n is 2 times b sub n minus 1. Remember this, if this is our current term, this is the one previous, and I'm going to add 3 to it. Previous, current. Okay. So my previous term, so the first term here is just 1. Oh, sorry. Okay. And then it gave us the first term to start with. I didn't want to make you guys think that that came out of magic. This was a piece of the puzzle that was given to us initially. So if b sub 1 equals 5, then calculate the remaining terms that we're interested in. So b sub 1 equals 5. Cool. Then what? b sub 2 equals 2 times the previous output, 5, plus 3. So this is 8 times 2 is 16. Then b sub 3 is going to be 2 times the previous output plus 3. So that's 16 plus 3 is 19 times 2 is 38. Then b sub 4 equals 2 times 38 plus 3 is 41, which becomes 82. And then b sub 5 equals 2 times our previous number plus 3, 85, equals 170. And then you could do b sub 6 dot dot dot, right? Woo, that sounds like a lot of work. All the way out to b sub 20. Now, these numbers are going to start to get massive really fast. Every time you multiply something by 2, you're creating an exponential function, because I have a level of multiplicative growth from step to step. So it's important to recognize that when sometimes these numbers get out of hand, that it doesn't make any sense to do all this work by hand. So instead we're going to go to our calculator, and we're going to turn on our calculator. I'm going to go through this with you really quick. Oh, maybe I can shift this over a little. Nope, not that way. That way, that way. I'm going to turn the overhead light off so you can see. Okay, it's a little better. So the first thing we're going to do is we're going to go to graph. And I already have mine inputted here, but I'll show you how I went ahead and did that. I went to menu and I went to graph type, and then I scrolled down until it said sequence, because I'm interested in a sequence, not necessarily a function, not an explicit function. So sequence is where we're going to define our recursive function. So I'm going to go 1 sequence enter, and then it popped up u sub 1 n equals, and then come in here a little, 2, I inputted this, times, and then I had to write, I had to actually click the button and the type font down here, u, and then 1, and then I added in the parentheses, n sub 1. So that's telling it the position. This right here is technically a subscript, so n sub 1 is a subscript, not u sub 1 times n sub 1, or I'm sorry, times n minus 1. This is the subscript that we had in our initial equation that we were just looking at. And then I add 3 to my last step, right? So I'm just typing in what we were working with when we were looking at the pen and paper stuff. And then of course I need initial term in order for it to know where to begin. So I told them the initial term, b sub 1, or in this case u sub 1, because that's how the calculator is defining it, is 5. And then when it first came up, this said 1, n, and then it said 99, but I don't want to go that far. I'm going to melt the poor little calculator's brain. So I'm just going to go to the 20th term because that's the one I'm interested in. An n step, I want to count by the first number and then the second number and then the third number. So it's going to defer to a step of 1 here. I hit enter. And whoop. Okay. I had to double click enter a couple times to get it out of there. So I went to menu when I initially did this because I couldn't see it. Window, zoom, fit, and it at least gave me sort of an idea of what I was looking for. And then I,
Hola.
out.
Oh, out. Goodbye.
And then I went to menu, trace, graph trace, and I hit enter. And then this little X came up, and as I look across the bottom of the screen right here, it's giving me the numbers. So I'm going to check and make sure that I inputted it right. So I'm going to check it against the numbers that we already had. 1 was 5, 2 was 16, 3 was 38. So those were the numbers I already calculated. So I'm going to scroll out here until I hit the 20th term. And here it's telling me that the 20th term is 5.77. So I'm going to write it on my paper. 5.77 times e plus 6. Well, what the heck does that mean? That's just a fancy calculator way of doing scientific notation. So this is 5.677 times 10 to the 6th. So you can calculate that out if you want, or you can just leave it in scientific notation. Now that would have been a lot of work to have to do it by hand, but lucky us, we have technology to do it for us.